Welcome to qnawire.
So here we can say that the heat lost by the metal is going to be equal to the heat gained by the water. So the heat lost by the metal is going to be equal to the heat gained by the water, and then we'll be able to find the specific heat capacity of the metal. So we can say that negative m of the mass of the metal times the specific heat of the metal times temperature final minus temperature initial of the metal is going to be equal to the mass of the water times the specific heat of the water times the temperature final minus the temperature initial of the water. And we find that C of M is going to be equal to negative mass of the water times the specific heat of the water times temperature final minus temperature initial of the water. And then this would be divided by the mass of the metal times the temperature final of the metal minus the temperature initial of the metal. So we can say that this is going to be equal to negative 1 kilogram of water times 4,190 joules per kilogram per Kelvin for the specific heat capacity of water times 22 minus 20 degrees Celsius. Let's do 22 minus 20 and then degrees Celsius. And then this is going to be divided by the mass of the metal, 0.500 kilograms, and then this will be 22 minus 100 degrees Celsius. So we find that the specific heat of the metal is going to be equal to 214.9 joules per kilogram per Kelvin. So this would be your answer for part A. Now for part B, it's saying which is more useful to store energy. Well, we can say that because the specific heat of the water is much greater than the specific heat of the metal, equal weight of the water is more useful to store thermal energy. So we can say that equal mass of water is more useful to store thermal energy because, again, based on the definition of the specific heat capacity, we can say that there's more thermal energy is stored in water per degree Celsius. My apologies, Celsius. And so for part C, they're asking us to, what would be if some of the thermal energy is absorbed by the styrofoam. So again, some of the metal's energy is absorbed by the styrofoam. However, the same temperature change is recorded. Therefore, we can say some Q of the metal is transferred to styrofoam. However, delta T is constant. So essentially, this means that the specific heat of the metal calculated in part A is going to be actually less than the real specific heat of the metal. So because the styrofoam actually absorbs some of that energy, and but the temperature change is the same amount, because it's recorded, it's an empirical data. We can say that the specific heat of the metal that it's calculated will be less than the specific heat of the metal, the actual specific heat of the metal, and that's just simply due to Q equals mc delta T. That is the end of the solution. Thank you for watching.